Hey guys, Assalamu alaikum. We are continuing the topic of ionic bonding right now. So we were saying that in ionic bonding, basically it is the target of all the elements of the periodic table that either they are losing electrons or gaining electrons regarding ionic bonding, and they want to match their new electronic configuration with elements of group number 8. Okay. So it means that our target is to achieve the electronic configuration of elements of group number 8. And I have told you in the previous lecture that they will not turn themselves into elements of group number 8. Rather, their new electronic configuration is matching with elements of group number 8. Okay. So now we can say this thing that after loss or gain of electron, how the things will be reached to that place and what will happen, all this story will be unlocked to you shortly. But right now, I was telling you one point in the previous lecture that elements have some specific number of electrons in their outermost shell, and that is associated with their group number. What is this linkage? I'm going to explain this right now. So, number of electrons in the valence shell. So, what is valence shell? The outermost shell is called as valence shell. Number of electrons in the valence shell is equal to group number. Okay, whereas total number of electronic shells is equal to period number. Okay, so what is the meaning of these two above statements? For example, let's consider sodium. It has an atomic number of 11. It has an electronic configuration of 281. So how many electronic shells are there in total? Three shells. Okay, three shells means how many electrons are there? 11. And how many shells are there? Three shells. So which period? Period number 3. Period number 3. Okay. And what about the number of electrons in the outermost shell is equal to 1. So it means that its group number is 1. Okay. So this is the information we can get from the number of electrons, from the electronic configuration, etc. Okay, let's prove this thing. So we have this periodic table. Okay, and this is here, and this is here, this and this is here. Okay, so we were saying this is lithium here, this is sodium here. Okay, so period number 1 contains only hydrogen and helium. Only hydrogen and helium. I should rub hydrogen from here. I will draw hydrogen over there. Okay, can you look at this right now that this is hydrogen, okay, and this is helium. Done. So they are existing in period number 1, and this is period number 2, and this is period number 3 right now. Is that okay right now? So we can say this thing that sodium is in period number 3, whereas it is in the group number 1. So this is the association of the electronic configuration with period number and with group number. After this whole discussion, I will teach you about the ion formation. Let's discuss how an ion is formed. What is an ion? We have already discussed this thing, but again, I'm telling you here what is an ion. An atom having charge is called an ion. Okay, so ion can be positively charged or can be negatively charged. Okay, let's discuss it further. A positively charged ion is formed by loss of electron, and it is formed by gain of electron. This positively charged ion is called cation, whereas negatively charged ion is called anion. So ions are of two types, and what is our ion number one? It is called cation, which is formed by loss of electron, and the anion, which is formed by gain of electron. Let's discuss it further. Okay, so we are saying here that electrons are negatively charged particles. Okay, this we have discussed already as well, negatively charged particles. And now we can say their gain their gain creates negative charge, okay, whereas their loss creates positive charge. Very clear, okay, positive charge, okay. And then ionic bonding, okay, two partners. What are those two partners? Metallic and non-metallic. Done. Metallic partners lose electrons according to their group number. Gain electron according to their group number. Okay. Make metallic partners make positively charged ion, whereas the non-metallic partners make negatively charged ion. All right. So this is how ionic bonding is progressing. This is how we are unlocking the mystery of ionic bonding. Let's make some of the compounds and let's discuss it further. Okay. So here I am considering the most famous example of ionic bonding, and that is called as sodium chloride. Okay, how to write sodium chloride? You can see this thing, N capital, A small, C capital, L small. Is this compulsory to write like this? Yes, it is compulsory to write like this. So a student should have a very clear idea that while writing a symbol of an element, the first alphabet should be capital, and the second alphabet, if it is existing, then it should be a small letter. F is the symbol for fluorine. It is never FL. I have observed this thing that students get excited and emotional and they are writing FL for fluorine. Okay. So please be aware of these facts. Okay. Now we are saying that sodium, it has an atomic number of 11, 2, 8, 1. Okay. So what it will do, it will lose one electron as it is a part of group number 1. So the new electronic configuration is 2, 8, whereas the sign for the sodium ion will be Na plus 1, and it will be now matching with neon. It is now matching with neon. Its new electronic configuration after loss of one electron is now matching with neon. It is not neon, brother, it is sodium ion, but its new electronic configuration, I mean to say the electronic configuration of sodium ion is now matching with neon. Okay, let's consider Cl. It is 18, it is 2, 8, 7. It is gaining one electron and afterwards it is 2, 8, 8, and it is now forming chloride ion. It is now forming chloride ion, and that's new electronic configuration is matching with argon. Okay, so look at here right now, we are saying that it is now matching with argon. Okay, so this is called chloride ion, and this is called sodium ion. Okay. One more thing which I will tell it to you on the next page is that name of metal atom and name of positively charged ion are similar. Okay. Whereas name of non-metal atom and name of negatively charged ion are not similar. Okay, not similar? Yes. All right, let's see what is the story. For example, sodium atom formula Na, sodium ion formula Na plus 1. All right. Calcium atom Ca, calcium ion Ca2 plus. All right. But in this case, name of negatively charged ion ends at the word IDE. All right, IDE. So it is, for example, chlorine atom Cl, chloride ion Cl1 minus. Is that okay? So this is how it is happening. Ending at the word, let me rub this, the word. Okay, ending at the word IDE. Okay, so you need to keep this thing very clearly in your mind that, for example, the negatively charged ions are, I'm writing few of them. It is fluoride, it is chloride, it is bromide, it is iodide, it is astatide. I'm writing astatide. Okay, for example, it is nitride. Nitride is also called as azide. You can see that nitrogen is a part of group number 5. It is gaining 3 electrons. That's why it has a charge of 3 minus. Phosphide 3 minus. It is also part of group number 5, phosphide. And then we can say oxide. Okay, then there is another. This is called as sulfide. All right, so this is how we are dealing with few of the names and their charges, and the negatively charged ions having names ending at the word IDE. Okay, let's make the dot and cross diagram for dot and cross diagram for NaCl. Okay, so Na is with dot, whereas Cl is with cross. So this is the key. So what is that key telling you? That electrons of sodium will be represented by a dot, whereas electrons of chlorine will be represented by a cross. Okay, so dot and cross diagram. So examiner will ask you that this is a very common question students are asking in the class, that examiner will ask us to draw the dot and cross, or can we change any other thing like a key, can we take triangle or something like that, etc. Yes, sometimes if examiner is not mentioning this very clearly, then it is a possibility, but this process to represent the structure is particularly having a name, and that is called a dot and cross diagram. Okay, so that's why it is advised that always make the key at the side and mention this thing that you are taking dot for this and cross for this, and never change the electrons. I mean to say that here I have mentioned the dot for the sodium, but when I'm drawing, I'm taking cross for sodium. So please be aware of that fact. Okay, so right now I'm saying that this is sodium, and we have said this thing that it has this electron 281, and it is losing one electron, and it is making 2 8. Whereas what about the chlorine? We are saying it is 17, it is 287, and it is gaining one electron and turning itself into 288. Okay, let's make this. Okay, so it is sodium. I'm changing the color. It is the first electronic shell, it is the second electronic shell, it is the third electronic shell. Yes, okay, and then I'm saying this is the change. It is now sodium plus 1. I should write it on the bracket. Okay, this is the first shell, this is the second shell, and these are the square brackets. No, not these. Is that compulsory to draw these? Yes. So what is the name of these square brackets? I have to draw it on my own. So what is this? It is a square bracket, and can you look at the top? It is a +1 sign at the top. Okay, so minus 1 electron. When sodium atom has lost 1 electron, it is having a charge of +1. Okay, so I can say you that the electrons of sodium are with the dot. Okay, so the first electron, second, second shell, 8 electrons. Why we have to make the electrons like in pairs? So that it is easier for anyone to find out the electrons and to count the electrons. And then there is 1 electron in the outermost shell. Okay, this electron will be lost, and then what will happen? Is that compulsory that always the electron from the outermost shell should go? Yes, it is a compulsion. Okay, we have discussed this thing not only in this lecture, rather in the previous lecture as well. Okay, so this is the electron which is lost, and now we are drawing the remaining electrons in the inner shell. You can see this thing that remaining electrons are as it is, whereas the only outermost shell electron is the lost electron. Okay, I am mentioning this. All right, so this electron is the lost electron. Is that okay right now? So now I am taking you to, this is called sodium atom, and this is called as sodium ion. Okay, what about chlorine? Look at this. First shell, second shell, third shell, and then what is happening? Okay, first shell, second shell, third shell. All right, so its electrons are with a cross. So this is the first cross, first shell electrons, 2 electrons in the first shell, then 8 in the second. 1, 2, 3, 4, 5, 6, 7. Okay, so 1, 2, 3, 4, 5, 6, 7, and this is the 8th electron. So from where this 8 electron has come? Sodium has given this 8th electron to chlorine. Is that okay? So this is the square bracket. Is that compulsory to draw? Yes, I'm saying it again and again. It is compulsory to draw. So sometimes what I'm observing is this, that students are writing E over here as well. electron over here, plus one electron, minus one electron, something like that. Please be careful. At the top of the bracket, these are the charges only, whereas the electrons are on these arrows. Okay, so please don't forget this thing, that where I have to draw the electrons, where I have to write the electrons, where I have to write down the charge. Okay, so this is called as chlorine atom, and this is called as chloride ion. All right, now I am taking you to another example, and that example is of MgO. All right, how I know this thing? First of all, that ionic bonding will occur over there, because I know this thing, that magnesium is a pure metal of group number 2, whereas oxygen is a pure non-metal of group number 6. So metal and non-metal combination will always originate only ionic bonding. All right, so we can see this thing, that magnesium has an atomic number of 12, electronic configuration 282, minus 2 electrons, 2 8, and that is called as Mg2 plus. What about the other right now? It is called as oxygen. It has an atomic number of 8, and so electronic configuration is 2 6. It will gain 2 electrons, as a result 2 8, and it will make oxide, O2 minus. It is called oxide ion. We have already discussed this thing on this page. Okay, so now I am on this back. Now this is the dot and cross diagram thing, dot and cross diagram. All right, and we can see this thing, that magnesium. Okay, so it is the first shell. All right, and it is the second shell, and this is the third shell, and now we are going to draw the electrons. So the electrons are with the blue, for example. We are saying this is the key, which is compulsory, dot for magnesium, and for oxygen it is a cross. Very clear that key should be there. So it is the first shell, 2 electrons, second shell, 8 electrons. It is written here, 8 electrons, and the third shell also has 8 electron. The second shell also has 2 electrons. The second shell has 8 electrons, whereas third shell has 2 electrons. Now what will happen? It will lose 2 electrons. As a result, it is magnesium. Now it is the first shell, it is a second shell. All right, and this is the square bracket with the +2 charge at the top. We can see the electrons are there. The 2 electrons will be there in the first shell, whereas 8 electrons will be remain there in the second shell. Only the 2 electrons lost are these 2 electrons, very clearly. Okay, I'm telling it again. These 2 electrons are the lost electrons. Okay, these are the lost electrons, very clearly. So here I am telling it again and again, that these are the lost electrons. Very clearly arrow is mentioned over there. Okay. Now I am telling you the structure for oxygen. This is oxygen. Okay. And here we are going to draw the first shell, and this is the second shell, and afterwards it is going to gain 2 electrons. Okay, electrons of oxygen are with a cross, and there are only 2 shells, so 2 electrons here, and the remaining 1 2 3 4 5 6. Okay, and then it is oxygen, and then first shell, and then second shell, and then this is this, this, and then this, a proper clear square bracket, okay, and it is -2. Why -2? Because it has gained 2 electrons. Here the crosses 1, 2, 3, 4, 5, 6, and then is the dot from where these dots are coming. These dots are the electrons which of magnesium which are gifted to oxygen to make it into oxide ion. So this is what called oxide ion. All right, so the top one is, this is called magnesium ion and magnesium atom, and the one is oxygen atom and oxide ion. So this is oxygen atom. So hope this is clear now. I will teach you one more example for aluminum oxide, Al2O3. First of all, how I will know this thing that ionic bonding will occur? Because aluminum is a part of group number 3 and it's a pure metal. Oxygen is a pure non-metal. So deliberately I have taken this example to tell you that how I will manage this 2 and 3 times the atoms of aluminum and oxygen respectively in the formula. Aluminum, I am telling it very clearly, it has an atomic number of 13, 2, 8, 3. It will 3 electrons. As it is a part of group number 3, it has 3 electrons in its outermost shell. It will lose 3 electrons from its outermost shell. From its valence shell will make this. This is called as aluminum ion. Oxygen 8, 2, 6, 2, 6. Okay, so it is going to gain 2 electrons as a result, 2, 8, and that is called as oxide ion. Guys, pay attention perfectly here. It is a little bit attention demanding. It is expecting more attention from your side. You can see this thing that there are total how many aluminums? There are total 2 aluminums. So one aluminum is going to lose 3 electrons. The second aluminum is going to lose 3 electrons as well. How many total electrons which are lost? These are 6 electrons which are lost. Okay, one of oxygen atom is going to gain 2 electrons. Total 3 oxygen atoms, they are going to gain total 6 electrons. So total 6 electrons are given and total 6 electrons are taken. Okay, so please keep this thing very clearly in your mind. Now we can say this thing that aluminum is represented by, let's see, okay, I'm not writing here because I need a little bit more space. We can make the key here. Aluminum electrons with a cross, whereas oxygen electrons with a dot. So it's a clear key over there. So this is aluminum. It is the first shell, and then it is the second shell, and this is the third shell. All right, and here is this arrow. This is again aluminum, first shell. There is one question as well. Most of the students are asking that as well. That, for example, let's write down the electrons and then I will tell you. So, for example, these are the electrons in the outermost shell of aluminum, and these are the electrons in the second shell, the 8 electrons. Okay, and these are the electrons in the first shell. Okay, so when the electrons from the outermost shell will go and when there will be no electron in the outermost shell, what will happen to that shell? What is a shell? Basically, shell is just an imaginary space. It's an imaginary area in which electrons are revolving. So when there will be no more electrons, there will be no more shell. Okay, so I guess this picture should be clear now. It is the electrons here, and we are going to complete the first shell. It is again the square bracket, and it is a +3 over here. So it is aluminum ion, whereas this is aluminum atom. How many electrons it will lose? 3 electrons. Very clear. Okay. And then I'm telling you about oxide ion. But guys, can you look at there that there are two Al2. So what you have to do is this. Multiply this by 2 and multiply this by 2 as well. So it means that we are performing, it is happening the whole procedure for 2 times. Is that clear? So this is what you need to keep in your mind. Now I am taking you to oxygen. Can you look at there right now? This is oxygen. All right, and this is the first shell, and this is the second shell. And what is happening? It is going to gain 2 electrons. This is the first shell. Here I'm writing oxygen over here. And this is the second shell. Okay. And then we can say that this is the square bracket with the -2 charge, as it is going to gain 2 electrons. So we have seen this thing that oxygen electrons are with the dot this time. Okay. Here 1, 2, 3, 4, 5, 6. Okay. So 1, 2, 3, 4, 5, 6, 7th, 8th. So from where these electrons are coming, I should mention these electrons a little bit more clearer. Okay, so these crosses are coming from aluminum to oxygen, whereas I have to draw the inner shell electrons. These are the inner shell electrons. Okay, so 2 electrons are gifted from aluminum to each of the oxygen atom separately. So total 2 aluminum are fulfilling the demand of 3 oxygen atom to turn them into oxide ion. Guys, here I would like to inform you that you can see at the top, aluminum after losing its electronic shell, after losing 3 electrons from its outermost shell, its new electronic configuration is 2 comma 8. Okay, and 2 comma 8 is now matching with neon. Okay, so Al plus 3 electronic configuration is now matching with neon. What about the oxide? Its new electronic configuration is also matching with neon. Sometimes both of the elements can approach the electronic configuration of the same element from group number 8. But in the example of sodium chloride, you have seen that their electronic configuration, both of them are not matching with the same element. You can see this thing that in case of chlorine, it is matching with argon, but in case of sodium, it is matching with neon. So they are different from each other. Sometimes they are similar, whereas sometimes they are different from each other. Okay. So this is what happening in sodium chloride, but in magnesium oxide, both of them are matching with neon. In case of aluminum oxide, they are matching with the neon. Here for oxygen, as you can see in the formula, 3 oxygens are completing their shells. So we have to do one more thing, and that is multiply by 3, and here multiply by 3 as well. Multiplying by 3 is important. Multiplying by 2 for aluminum is important, just to tell that this process is happening for these many times. Okay, so these are the 3 examples for sodium chloride, magnesium oxide, and aluminum oxide, to clarify, to explain the concept of ionic bonding in some of the compounds. In the next lecture, I am going to discuss with you the properties of ionic compounds, how the structure can be depicted, what is the crystalline structure of ionic compound, what is the lattice of an ionic structure. We are going to discuss all these things in the next lecture. Thank you very much, guys. Take care of yourself. May you rise and shine in chemistry due to this channel. Thank you very much.